So welcome to Sundar's lecture. This is third lecture and we have taken a problem in the last lecture and this is that problem. So it has three loops and we have found what is I1 and I2, I3 by using KVL expressions, and we have also found what is the current in all resistors, right? You can see that we have found all the resistors current by using KCLs, and we have taken a very important concept, that is voltage between any 2 points. And you see this one, voltage between any 2 points via any path in an electrical circuit will be equal. So that is very important, right? I have told you already, because this concept we will use so many times. We will use so many times in the future lectures, right? So in today's class, we will take a new problem, and you see this is the problem. See, find current in all resistors. Now you see we have two loops. So we are going to write the KVL expression and we have two loops. This is the first loop and this is the second loop. There is no difference in that. And you see there is a current source here. So if you want to write, so first if you see any problem like this, first of all what you do, you just assume the current directions. There is no difference. You assume current directions like this. So this will be I1 and this will have to be I2, and I will tell you, you have to assume this current direction. This I2 should be whatever the current direction given here, because since it is given already. You see, we have seen the problems using voltage sources in the previous lecture, but if current source is given in any one of the loop, you see this is only connected to the second loop. This 2 ampere source is only connected to the second loop. So you have to assume that I2 has to be in this direction, that is clockwise direction, since it is already given. You cannot take this current direction in anti-clockwise direction, right? That you have to keep in mind. And one thing, it is very interesting here. What is that? You see, this is in the second loop, right? This 2 ampere source in the second loop. So you can directly write that I2 will be equal to 2 amperes. That is already given. That is already given. And you need to find only I1. And if you know what is I1, then you can find what is the current in 4 ohms resistor as well as 6 ohms resistor, right? So for that, what you do, you just write the current direction. So this will be I1, and I1 this will be I1, then I1 will come in this direction. So what it will be, so this will be I1, and that's all, right? It will be there is no any other resistor present here. So if you want to write I2, then I2 is in this direction. There is only one resistor. So I2, if I draw I2, then I have to draw in this direction. So how I will draw? I will draw this as I2. Right? This will be now I2. That's all, right? There is no any other resistance in this loop. So now you write the KVL expression. How will you write the KVL expression? Start from this point, go in this way, come here, and then you end with this point, right? So I will write the KVL expression. So from I am starting from this point. So what happens? I will go in this direction. So minus 2, from minus 2 plus, I will write down fastly because we know everything, right? So plus 10, and then if I go in this direction, I will go in the same direction as this I1. So I have to put minus 4 I1. Then I have to come from here to here. You see here also I am going in the same direction. So I have to put obviously minus 6 into I1. Then if I come in this direction, I am coming opposite to I2. This I2 is coming in the opposite direction, right? So what I have to do, I have to put plus 6 into I2. Then I am traveling from plus to minus here, right? So from plus to minus, which means I have to put minus 5. That's all, right? There is no other elements present in the loop. So this one I have to put equal to 0. Now you see, I will simplify this expression. There is two values, that is minus 4I1 and minus 6I1. So what I will get, this is 10 minus 10I1 plus 6I2 minus 5 equal to 0, right? So if I simplify further, so this 10 minus 5 becomes plus 5, and I will bring this all other component, all other terms to the right hand side. So what I will get, if I simplify further, I will get 10I1 minus 6I2 will be equal to 5, right? So this is my expression number 1. So this is my expression. I have brought this 10I1 and 6I2 to the other side. Anyway, so this is the expression number 1. And what you know already I2 is equal to 2 amperes. Just you substitute here, substitute I2. What you will get? 10I1 minus 6 into 2, which is equal to 5. What I will get? 10I1 minus 12 is equal to 5. And if I bring this to other side, this 12 to other side, 10I1 will be equal to 17. And what happens? If you simplify this, you will get I1 is equal to what? 10 by 17 by 10. So you will 17 by 10, you will get what? 1.7. So therefore, I can write here I1 will be equal to 1.7 amperes. That's all. Right, that's all. So I am getting both answers as positive. Since this is already I have taken in this direction, that is I2 is equal to 2 amperes and I1 is 1.7 amperes. So whatever the current directions you have assumed here, everything is correct, right? So what I have to do? I have to draw the diagram. So this 4 ohms resistor will carry what? Only I1, right? So I can directly write I through 4 ohms resistor will be equal to I1, and that is nothing but it is 1.7 amperes, no difference. But if I want to find what is the current in the 6 ohms resistor, then what I have to do? I have to write the KVL expressions in this particular point. So I will draw the diagram. Anyway, I will draw the diagram. So now you see I have taken the diagram again. You see this is this one, this 4 ohm I through 4 ohms resistor I have found, because this is only connected in the first loop. So I1 will be equal to 1.7 ohms, that will flow in the 4 ohms resistor. Now I want to find what is the current in 6 ohms resistor. So for that, what I have to do, I have to assume that this node as A, this is I will take a different color. So this will be node A. So what I have to do? So KCL at node A. You see, this will be I1, that is 1.7 amperes, and this will be I2, but this current, that is I through 6 ohms, I have assumed this one. If I get negative value, then I have to reverse this direction, right? So if I apply KVL, what I will get? So put equal to symbol. You see this 1.7 amperes is coming towards the node, so I have to put it in the left hand side. So 1.7. Then this 2 ampere is going away. So I have to put it in the right hand side. And you see this I through 6 ohms also coming away from the node. So I have to put it in the right hand side. So I through 6 ohms. So if I simplify this, I through 6 ohms will be equal to 1.7 minus 2. So I am getting it in the negative value. I am getting it in negative. So I through 6 ohms becomes minus 0.3 amperes. Right? So you see, if I get negative answer, that means I am getting a negative answer, since this current direction, whatever the current direction you have assumed here, that is wrong, because I am getting negative value. So what you have to do? Simple. You put plus, no problem. And then what you do? You change this, you reverse this current direction, which means this is wrong, this is wrong, this is wrong. What you have to do? This will be like this, and this value will be 0.3 amperes. That's all. That is how you need to reverse the current direction, because everything is assumed by us. I don't know whether it will be plus or minus, but if you are what to say, if you are well structured or well known person, you would have directly written, since you see 1.7 amperes is coming to this node and 2 amperes is going away. How 2 amperes will go away? No way, right? Then you should give here 0.3 amperes so that 2 amperes will go away. Anyhow, that will come if you solve many problems and if you take so many risks to understand the concepts. Anyhow, so this is how you need to solve the problems. And now you see, if you see any current sources in any one loop, particular loops, then you don't panic. The value is already given. That loop current is already given. This will be also applicable if this current source is only in the first loop. Then you have to take that I1 is equal to 2 amperes directly, right? So this is one kind of problem, right? And we will take another problem now. For that, we will go to the next page. And you see, this is the second problem. The question is same. Find current in all resistors. There is only three resistors. This 2 ohms, 4 ohms, and 6 ohms. And this 2 ohms and 4 ohms is connected in the first loop. So I1 will flow in 2 ohms and 4 ohms. And the 6 ohms is connected in the second loop. Obviously, I2 will flow in the 6 ohms resistor. Anyway, there is no problem in that. But you see, if I see any problem like this, first what I have to do, I have to draw the current directions. So if I will assume this is I1, and I will tell you I have to assume this in only clockwise direction. Why I will tell you? You see, if I assume that I1 is in this direction and I2 is in this direction, if I want to write the KVL, I have to start from this point. So I will mark down the current directions. So this is I1 and also this is I1 and this will be only I2, right? So this is how we can mark the current directions. And now you see, if I start from this point, I will go from minus 2 plus, that is plus 4. Then I am going in the same direction, so minus 2 into I1. So I am going in the same direction, so I will get minus 4 into I1. Then I will come here. And you see, I cannot tell what is the voltage here since I don't have any resistor or it is not at all not a voltage source. So I cannot say what is the voltage in this point. So for that, if you see any problem like this, which means any current source connected between two loops, that means this current source is common to first loop as well as second loop. These kind of problems, we are calling it as super mesh problems. Super mesh problems, right? If super mesh problems has a different procedure. You see, if you see any problem like this, then you have to assume this I1 in clockwise direction as well as I2 in clockwise direction only. Or you can assume it in both in the anti-clockwise direction. But we, uh, our procedure, we are going to solve this problem by assuming only in the clockwise direction. How? Then what you have to do, you just write the KVL expression around this 2 ampere source, which means you go in this way, come here, and then come here. You have to write the KVL expression like that. Okay, fine. Now I will write the KVL expression. You see, so start from this point. You go in this way, that becomes minus 2 plus. So minus 2 plus you are going, so it will be plus 4. Then it will be minus 2 I1 minus 4 I1. Just I am going in this way, right? So I am going in the same direction, minus 2 I1. I am going in the same direction, so minus 4 I1. So I am going in the same direction again here, so that also becomes minus 6 I2. Then I am coming from plus 2 minus in this way, so I will get minus 6. So that's all right. There is no any other elements in this way, in this path. So that it has to become 0 now. So you simplify this expression now. This will be 4 minus 6, that will be minus 2 minus 6 I1 minus 6 I2, right? It will be equal to 0. So I will bring everything to the other side. So this becomes 6 I1 plus 6 I2 will be equal to minus 2. So this is x. So we have written the expression now. Then what you do, you apply KCL in this point now. So what you will get, you see I am going to apply KCL. That means I am going to take this as node A, right? You see I I1 is coming in this way, I2 is going away and 2 amperes is coming here. So what you do, so I will write here. So KCL at node A. So if I write KCL at node A, what I will get, I have to put equal to symbol. You see I1 is coming towards the node, so it will be in the left hand side. So that will be I1, and you see this I2 is going away from the node, so that has to be in the right hand side, that is I2, and you see this 2 amperes is coming towards the node, right, in this way, so it has to be in the left hand side. So this is one expression, make it as expression number 2. Now what you can do, I2 can be substituted as I1 plus 2, you just do you just put I2 as I1 plus 2 in this expression. So what you will get, that means substitute expression number 2 in 1, what you will get. So in I1 you keep I1 as it is, plus 6 into what is I2, I2 can be written as I1 plus 2, that can be, that will be equal to minus 2. So you simplify this one, so 6I1 plus 6I1 plus 12, right, which is equal to minus 2. So this becomes now what, 12I1 then will be equal to, if this plus 12 is goes to other side, that becomes minus 14. So I1 will be equal to what, minus 14 by 12. So minus 14 by 12 you will get I1 will be equal to minus 1.167 amperes. You just simplify, if you simplify you will get this answer, right. So this is the I1 value. So you just substitute this I1 in expression number 2, so that you will get I2, right. So what we can do now, so from expression 2, so from expression 2 what you will get, I will get minus 1.167 plus 2, right, I have substituted I1 will be equal to what, I2, and if you simplify this you will get what, I2 will be equal to what, 0.833 amperes. That's all. So now you see I1 is in negative. We got I1 as negative value. So what? So this assumed current direction is wrong. You have to reverse the current direction, right? You have to reverse the current direction. And so I will draw the circuit again so that you can easily understand. So I have drawn the circuit and you can write what? So this will be now I1. This has to be reversed. So this will be I1 and this will be I2. And what is this one? This 6 ohms resistor will get what? 0.833 amperes. And this 4 ohms resistor will get what? 1.167 amperes. And as well as this 2 ohms resistor will also get 1.167 amperes. Since you see this 2 ohms resistor as well as 4 ohms resistor connected in loop 1. So that will have only I1, and the 6 ohms resistor is connected only in the loop 2, so that it will get only I2. So I have written directly. So if you reverse the current direction, what you have to do? You have to put plus, directly plus, right? So this is one of the procedure to find super mesh problems, right? Now I will tell you another one procedure. We will take the same problem again, and we have taken the problem again. You see again, we have to find current in all resistor, everything will be same. So if you see two loops, what you have to do, obviously you have to assume this is I1 and this is I2. Let us assume that this is the first time we are seeing this problem. Anyhow we know this problem, right? Already we have seen that this current direction I1 will be in the anti-clockwise direction. Anyhow I am not assuming in the anti-clockwise direction, since I know this, because we have not seen this problem. We assume that we have not seen this problem already, right? So this will be I1 now. So what I am going to do, I am going to write the KVL expression now for this two loops. So for that what I have to do, so I will write this is I1 and this is also I1 and this is I2. That we know already. Now I will start from this point. Anyhow, I will start. So what I will do, I will write, right? So KVL at loop 1. KVL at loop 1. So you see, I will start from this point. So I will go in this way because my I1 is in this way. So if I go in this way, so that 4 volt source becomes plus 4 because I am traveling from minus to plus. Then I'm going in this way. This I1 is in the same direction. I will write the KVL expression now directly because I don't need to explain because you people are well known to this concept. So then this will be in the same direction, so that it becomes minus 4I1. Then you see, if I come to this point, what I am going to do? I am going to do one thing, that I am assuming this is plus, this is minus x. What is this x now? X, which is nothing but voltage between these 2 points. I don't know what is the voltage. So what I am doing, I am just putting it as x. Just assume x. So from, you see, now this current is flowing from plus to minus. What is the voltage value? X. So what you can do now? You can obviously put this is minus x because that is voltage, which is equal to 0. Now you simplify this. What you will get? Um, this will be minus 2 minus 6I1 plus 4 minus x is equal to 0. That is one thing. Or else you bring everything to the other side. So 6I1 plus x will be equal to what? 4. That is expression number 1. Right? That is expression number 1. Now what you do? KVL at loop 2. Right? KVL at loop 2. You will get KVL at loop 2. What you will get? So you start from this point. You have to travel like in this way, right? Clockwise direction. You start from this point, you go in this way. So you see there is a voltage. You are going from minus to plus in the x voltage. So what you will get? You will get plus x here. So plus x. Then you go in this way. You are going in the same direction as I2. So you have to put minus 6 I2. Then what you can do? So you come in this way from plus to minus. You are now traveling from plus to minus in 6 volt source. So what you do? You put minus 6. So that will be equal to 0, right? There is no any other element. So that will be equal to 0. So now what you do? You bring everything to the other side. So you will get plus 6I1 and you bring minus x to other side, minus 6. Minus x will be equal to what? This becomes now minus 6, right? Because you have brought these two elements to the other side. So this is now equation number 2. Now what you do? You add equation number 1 and 2. 1 plus 2, what you will get? So 6I1 plus x will be equal to 4, that is expression number 1, and 6I1 minus x will be equal to what? Minus 6. So if you add these two elements, what you will get? If you add these two, you will get plus 12I1, and this term will be cancelled out. That is 0, because plus x minus x, if you add these two, you will get what? 0, right? So if you add these two, oh, is there any wrong we have done? 1 minute. Sorry, I have made a mistake. This is not I1, this is I2, right? So I will anyhow rough this. This is actually wrong, right? This is actually wrong. Sorry. So this will be what? 6 volt, right? This will be 6 volt, right? So now you simplify this one. We will get values. What we will get? You see, you just keep this 6I2, you bring that to other side. What you will get? That minus x will be equal to minus 6, right? So this will be expression number 2. Now what you do? You apply KVL here, KCL here at this node A. So what you do? KCL at node A. So you see I1 is coming towards the node. So you put equal to symbol, I1 is coming towards the node. So what you will get? You will get I1 in the left hand side, and I2 is going away from the node. You will get I2 in the other side. Then this 2 ampere source is coming towards the node. So what you will get? You will get plus 2 here. So now what you do? You just substitute this I2 in this expression. That means this I2 in the second expression now. So what you will get? 6 into, instead of I2 I will get I1 plus 2 minus x will be equal to minus 6. So if you substitute, what I will get? 6I1 plus 12 minus x will be equal to minus 6. So you bring this to other side, 6I1 minus x will be equal to minus 18, right? Minus 18 plus 12 will go to other side. So this is expression number 3. Now what you do? You see these two can be easily solved, right? So you add 3 plus 1. What you will get? 6I1, that is 3, expression number 3 will be equal to minus 18. And what is the first expression? 6I1 and this will be plus x will be equal to 4. And if you add these two, you will get 12I1. This 2 will be now cancelled out, will be equal to, this is nothing but minus 14. Right? You are getting like this. So you can easily find I1 now. What is I1? I1 is equal to minus 14 by 12. What you will get? So I1 will be equal to minus 14 by 12. That is what we have got in the last problem. That which is equal to what? Minus 1.167 amperes. That's all. Right? Now you substitute this I1 in expression number like this one. I2 is equal to I1 plus I2. I2 is equal to I1 plus 2, right? So now you substitute and you get the value. So how you can write? I2 will be equal to what? I1, that is minus 1.167 plus 2. So what you will get for I2? I2 will be equal to 0.833 amperes. That's all right. Now this current direction is in the is negative. So what you have to do, you have to reverse this direction. Everything whatever we have seen in the last problem, right? Whatever the answers we have got by this method too. You see, we can also follow this procedure. Anyhow, you can also find what is x here, because if you know what is I1, then you can put it in this expression, you will get x. What is the voltage at between these 2 points also can be found by this method. Anyhow, you see, you take electric circuits, you can solve problems in many methods. In many methods. Wow. You see, we are playing with electric circuits now. If you are very interested, then you can apply many techniques to the same problem. Approach the electric circuits. Get to it. You can explore many things in electric circuits, right? So you can use any of these methods. But the super mesh problem is very helpful in examination point of view, because everywhere you go, you can see the super mesh problems in the question papers, right? If you have any doubts, you please post it in the comments. I will reply for that, and we will take up different topics in the upcoming lectures, which means we will go for inspection method. We don't need to write the KVLs now, KVL expressions. We can directly write the expression by seeing the circuits. That will be very interesting, right? Anyhow, thank you. Have a nice day. Expression number 1, right?